Chapter 2 Maps, Time, GIS, and Remote Sensing. 2.8 Remote Sensing. So, what is remote sensing? We can define remote sensing as the collection of data about an object from a distance. In fact, we do remote sensing as beings. We collect information with our eyes, with our ears, and we do this from a distance. We can see quite far. We can see things occurring, and we can hear over distances, and even smell. Right? How many times have you walked down a street and smelled a delicious meal being made at a restaurant and decided you were going to go in? We have used technology to enhance our ability to do remote sensing. And there are two common pieces of technology used that obviously can do remote sensing, and that's cameras and other types of sensors that we position on things like planes, satellites, and even drones. So here's an example of an early aerial photograph taken from above of New York City in 1919. So this would be an example of a remotely sensed image done through photography. Sensors to do remote sensing are often designed with specific purposes, and often they are designed to measure specific wavelengths of electromagnetic radiation. Some common examples of using remote sensing include mapping, agriculture, forestry, city planning, weather forecasting, and other forms of scientific measurement. We've all seen Google Earth. Google Earth uses images from either aerial photographs or from planes or from sensed images using fancy sensors that are aboard satellites. The first remote sensing was done in the late 1800s, and it involved the use of simple cameras that were sent aloft using balloons and kites. And guess what they were used for? War, to see troop movements and troop locations. Today, various types of sensors are being used on a variety of platforms. This table shows some of the major regions of the electromagnetic spectrum. So they're listed there: gamma ray, X-ray, ultraviolet, photographic ultraviolet, visible photographic, bandwidth, infrared, reflected infrared, thermal infrared, microwave or radar, and radio wavelengths. Each one of these has a different ability to sense objects in the environment. Information collected depends on spectral characteristics of the sensor, what wavelengths it can view, and the types of objects being sensed. As I said, early remote sensing used simple black and white photography. Then in the 1940s, 1950s, this photography was improved through the use of color images. And as we can see in this example, color can with color, it's a lot easier to see various types of information in imagery. So here we have the two similar images of a street from above, showing the homes and trees. On the left side is the color image, and you can see there's a lot more information that's available than on the image that was done in simple black and white. Satellite remote sensing began in the early 1960s. This is when we started sending satellites up into space, and usually attached to these satellites was some type of imaging sensor. Early on, it was cameras. Then later on, it was more complex sensors, like the sensors we currently use in digital cameras. One purpose of these early satellite remote sensing systems was to monitor Earth's weather. We had very little information about what was going on over the oceans, and if you live on the west coast of North America, much of our weather comes from the Pacific Ocean. So being able to see what was churning out in the Pacific Ocean and traveling towards one's shores was a very important thing to have happen. The first meteorological satellite was called TIROS-1. It was launched April 1st, 1960. Currently, we have many different types of meteorological satellites in space monitoring the atmosphere for a variety of different weather and climate features. Here's a picture of the TIROS weather satellite, and here's an image that it took of the coast of New Zealand in August 24th, 1964, and that white swirling mass looks like either a mid-latitude cyclone or maybe a hurricane. This image shows some of the satellites that are currently observing our atmosphere. As you can see, there's quite a few. And now the images are quite stunning that can be sensed with modern day satellites. So here we see an image of Hurricane Harvey from August 25th, 2017, and this image was was produced by the GOES-16 satellite and the sensors that are aboard it. We can take these images and turn them into a video. So here we can see Hurricane Harvey swirling its central eye as it moves towards the coast of Texas. And this particular storm dumped a lot of precipitation on Texas, in places almost 60 inches or almost 2 meters of rainfall occurred. Here's another image from the GOES-16 satellite of Hurricane Harvey and its landfall on August 26, 2017. And this image was taken at night, so sensors that are up in the satellite can view both visible and other wavelength bands so that they're able to see features in our atmosphere at night. Remote sensing satellites also have been used to look at other types of objects on the ground surface, not just weather features. In the 1970s, a series of satellites were launched into the atmosphere to observe what was going on the ground surface. There was the American series called Landsat, and France sent up a set of satellites called Spot. Both Landsat and Spot sensors were specially designed to image features on the Earth's surface. Canada has even sent up its own remote sensing satellites, and we've sent up a series of satellites called RadarSat, and these use microwave emissions to do active remote sensing. And their primary use is to monitor ice flows on the east coast of Canada. Here we can see the Landsat 7 sensing image or sensor. It's called the Enhanced Thematic Mapper, and it's quite a complex and large device. Spot is able to do false color images, so it's the equivalent of infrared. And here we see an image from central Pennsylvania, USA, and we can see some unique geologic features. They look like folds in the landscape using this false color sensor and its imagery. Here is an image taken from RadarSat-1 of a part of Nunavut, Canada, and there's three features there, A, B, and C. Take a look at the notes. I can't remember exactly what they are, but they're A is obviously a lake, but B and C are some type of geologic features. And RadarSat is also used to some degree for geologic purposes. We use this remote sensing imagery every day. If you use Google Map or the Apple Map app, and basically what we have here is remote sensing and geographical information systems combined, so that we can view the Earth's surface and see the features and see roads and buildings and so on. And here is an image from Google Map, a remotely sensed image of the Okanagan campus of the University of British Columbia. And I can see there's a lot of cars in the parking lot, so it's definitely pre-COVID.